Hello students, welcome to chemistry calculation for WAEC, NECO and JAMB UTME, and the first aspect we are looking at in the calculation is mole concepts, and also we are going to look at in stoichiometry. So we are looking at mole concept and stoichiometry, and now we are going to look at the first calculation here that we have, as says calculate the mole in 18 gram of glucose. The mole in 18 gram of glucose. Let's see how we solve this in the solution. In the solution, we have mole to be equals to mass given divided by the molar mass. And here we know that the molar mass of glucose, and that's C6H12O6, and in that case you're having it being calculated as we have C times 6, as you can see, plus H times 12, as you can see, and O times 6, as you can see. So C, which is carbon, is 12 times 6, then plus hydrogen, which is 1 times 12, then plus oxygen, which is 16 times 6. So from here we are going to see it that this is going to be 72 plus 12 plus 96, and here we are going to have it as 180. So 180 gram per mole. So from here we could see that what's the next thing that we have here? We want to calculate the mole. Now the mole, as we have said, is equals to mass given, and the mass given here we know it over molar mass. Mass given is 18.0 gram, and molar mass is 180 gram per mole. And from there you are going to have this as 0.1 mole, and that's the answer to that question. It's 0.1 mole. You can see the way it has been solved in a step by step and demystified way for you to have a deep understanding of calculation under mole concept and stoichiometry. Okay, let's see what we have in the second question here. And the second question says calculate the mass of 0.75 mole of calcium triisocarbonate 4. So you have to calculate the mass. Remember, you are calculating the mass here, and from there we could see that since we know that mole, let's look at the solution. Mole is equals to mass over molar mass, and from here we can calculate the mass as going to be mole multiplied by molar mass. So from there you could see that what is now the molar mass, because you have the mole already. Molar mass of calcium triisocarbonate 4, that's going to be Ca plus C plus O times 3. Ca is 40 plus 12 plus 16 times 3, and from there we could see that this is going to be 40 plus 12 plus 48, and that gives us 100 gram per mole. So how do you now calculate the mass? As we have it, once again, the mass is equals to mole times molar mass. Please take note of the formulas. And what is the mole? 0.75 mole, then times 100 gram per mole. So the final answer there, as you can see, is going to be 75 gram. That's how we calculate that mass. You can see the way it has been done in also in a demystified way, step by step on how to solve the question. Okay, now let's see what we have under this third question. Calculate the molecules. Calculate the molecules. Now we have to calculate the molecules in 0.25 mole of ammonia gas, NH3. So let's look at what we have in the solution part of this. So we are asked to calculate the molecules, and here the number of molecules is equals to mole times Avogadro's constant. Avogadro constant. So, and the Avogadro's constant that's Na, always give it as N capital A, subscript capital A, is equals to 6.02 times 10 to the power 23 times 10 to the power 23. So in this case, number of molecules is now going to be the mole, which is 0.25 times 6.02 times 10 raised to the power 23. So from there you could see this is going to give us 1.505 505 then times 10 raised to the power 23 molecules. So that is how we calculate the question. 1.505 times 10 to the power 23. And since even the Avogadro is given up to 2 decimal places, you can have this one too as 1.51 then times 10 to the power 23 molecules, whichever way, and that's the number of molecules that you asked to calculate. Okay, now for this number 4 question, calculate the atoms in 11.2 dm cube of oxygen at XTP. XTP means standard temperature and pressure, and we are going to see that. Let's see what we have in the solution. We are asked to calculate the number of atoms, and the number of atoms, just like what we have in the above example, is also equals to the mole multiplied by the number of moles multiplied by the Avogadro's constant. And in that case, we are going to look at it. How do you calculate the mole here? Mole of oxygen. And since we are given at standard temperature and pressure, we are going to look at it that at XTP, the volume is 22.4 dm cube. That's standard volume, that's molar volume, and this one equals to 1 mole at XTP. The molar volume, unlike masses, which you calculate the relative atomic masses or relative molecular mass, in the case of gas, the molar volume for gases is equals to 22.4 dm cube, 22.4 dm cube, and that is why we say it's equals to 1 mole as you have it here. So in this case, we have our mole is calculated as volume given divided by the molar volume. Now the molar volume is given already as 22.4 dm cube, and the volume also is given as 11.2 dm cube divided by 22.4 dm cube, and this will give us 0.5 mole. 0.5 mole, as you can see. Then the next thing is now for us to calculate that the atoms, number of atoms. Now each atom, each oxygen molecule has 2 atoms. I have it that each oxygen molecule, which is O2 molecule, has 2 atoms. So in that case, number of atoms is going to be 0.5 times the number of atoms, which is 2, then times Avogadro's constant, which is 6.02, times 10 raised by 23. So from here, this is going to be 0.5 times 2 is 1, and times 6.02 times 10 by 23. So the answer is going to be 6.02 times 10 to the power 23 atoms. That's how we calculate that. As you can see, that's the easiest way to calculate it right from the beginning in a demystified way. You can see the question and see the step by step of calculating it. Now let's what we have in the 5th question here, that says determine the empirical formula of a compound that contains 10 grams of hydrogen and 80 grams of oxygen. So let's look at what the solution is all about. In the solution here, we could see that we have hydrogen and oxygen. Hydrogen, we have oxygen, and here we have to note the mass of each element. I have it there that note the mass of each element, and that's for hydrogen, the mass that is given is 10 gram, while for oxygen is 80 gram. So the next thing is divide the molar masses by atomic masses, as we have it that divide the masses by atomic mass. Atomic masses. So in that case, this is going to be divided by hydrogen, which is 1, and divided by oxygen, which is 16. So from here you have this one as 10 mole, and here also we have this as 0.5 mole. Sorry, 5.0 mole. That's 5.0 mole. And now the question is saying that you have to divide by the lowest figure to obtain the ratio. To divide by lowest figure to obtain the ratio. You obtain the ratio, and this is going to be over 10, and here also is over 10, and from there we could see that this is going to be divided by the smallest. The smallest is not that's 5.0, and this is 5.0, and from there we could see that this is going to be 5 goes there 2, 5 goes there 1, here 1 1, so this is 2, this is 1. So we have the formula now going to be H2O, H2O, 2 is there for H2, and also 5 is there to obtain. Now you can see the way it has been solved in a demystified way, and that's how you calculate the empirical formula of a compound, just step by step way of doing that, just like you can see. Okay, this is coming from Covenant Achievers Academy, where you'll be solving questions like this in all aspects of physics, chemistry, mathematics, and even further mathematics, to enhance and ensure that students writing exam have a higher and a good grade at the end of the exam. Having watched what we have on this, ensure you subscribe, like, and share, so that whenever any video is coming in, you can be forced to have it. Thank you.